So our next lesson is going to be talking about scalar equation of lines on the plane. So we have a normal vector. So the normal vector to a line is any vector that is perpendicular to the line and is denoted as n with a bar or n vector. The normal vector is equal to n1 and n2. So if a line is perpendicular to another line, what is the slope of the perpendicular line in comparison to the slope of the line is perpendicular to? Learn this in grade 9. How do I determine a perpendicular slope if I have a slope already of a line I want to be perpendicular with? Should be super easy. I would be very concerned if you guys didn't know how to find the perpendicular slope. Oh no. Yep, so the dot product is 0, or you just take the negative reciprocal. So let's find a normal vector for each line. So for A, I have y is equal to negative 4x plus 7. My slope is negative 4. What would my perpendicular slope be to that line, negative 4x plus 7? Should be pretty easy. 1 over 4. So my direction vector for my regular line, for my original line, is going to be 1, negative 4. However, my normal vector for my perpendicular line is going to be 4, 1. Now let's take a look at the next one. B. So for B, I know that my direction vector is going to be 3, 4. So again, this is x, this is y. So if I were to write a slope, it would be m is equal to 4 over 3. Who can tell me what my normal vector is going to be given this information? So what's the negative reciprocal of 4 over 3? It is going to be negative 3 over 4, sorry. Whoops. Which is negative 3, so 3 over negative 4. Which means my normal vector is going to be 3. This guy's going to be negative 4. I messed that up. Hold on. Whoops. Completely wrote it the wrong way. I'm so dumb. My bad, guys. So 4, 3, x, y. So my regular slope is 3 over 4. My perpendicular slope is going to be negative 4 over 3. Which means that normal vector is going to be 3, negative 4. That was my apologies. The rise, so whenever you have rise over run, in grade 9, you always associated the negative, the y-axis with the rise and the run. So if your slope was negative, your rise would be a negative number. So negative 5 over 2, it means you're going 5 units down and 2 units to the right. Remember, when we read a graph, we read it from left to right. So we read it from left to right. So if I have a graph like this, I have 2 points over here. So let's say this is 2 and 3, and this is 0 and let's say 7. So because I'm reading graphs from left to right, I'm going to be going 4 units down. 1, 2, 3, 4, which means my rise is -4. And I'm going 2 units to the right. 1, 2. So again, your rise or your y will always receive the negative, not your x. Does that make sense? All right. So the dot product of a normal vector and a direction vector is always 0 because they are perpendicular. This is key to the use of normal vectors in 2 dimensions. So now I want to find the equation of a straight line with the normal of 2, 3 that passes through the points 4 and 5. And I want to write this equation of the line in standard form, which is ax plus by plus c. So I need to pick a random point P that is xy. So I need to suppose, like the lesson before, suppose I have a point x comma y is a random point. So I have this guy over here. I have my PO, which is a point right here. And I have my normal vector, which is perpendicular to PO. Now I have this random point over here, which is P, X, Y. So from the previous example, or from the previous lesson, I know that P0 times my point is equal to x minus 4, y minus 5. And in order for it to be perpendicular, the dot product between n, between my normal vector, and P0 times P is going to give me 0. Which means that my normal vector, 3, -2, dot product x minus 4, y minus 5 is equal to 0. And now I can use this to come up with an equation in standard form. So I got 3 times x minus 4 minus 2 times y minus 5 is equal to 0. So I get 3x minus 12 minus 2y plus 10 is equal to 0, which means that 3x minus 2y minus 2 gives me 0. And this would be my equation of the line in standard form. So if you notice, the coefficients in front of x and y are components of the normal. So they give you the normal vector. Thank you. Did Anna say if she was alive? Disappointed in her. I am very disappointed. I should dock her marks for not paying attention. So now with that said, let's go on to examples 2 and 3. So now we're gonna find, she wouldn't be too happy. She should be paying attention in class. So suppose a vector P0 times P along a line from a fixed point P0, which is x0, y0 to any other point P, x, y is perpendicular to a normal n, n1, and n2. So we just proved from then that P0 dot product n gives me 0. So again, let's say I have my points here. This is P, x, y, and this is P0. Well, let's make this P0, this x0, y0. So my line is going to go like this. Sorry for making it messy. And this is going to be my normal vector over here. So I need to prove that the dot product is actually going to give me 0. Using my definitions or my terms I have here. So I know that x minus x0, comma y minus y0, dot product n1, comma n2 is equal to 0. So again, I take n1 times x minus x naught plus n2 times y minus y0 gives me 0. So now when I expand it, I get n1 x minus n1 x0 plus n2 y minus n2 y0 is equal to 0. So I'm left with n1 x, which gives me my a, plus n2 y, which gives me my b, minus n1 x0 minus n2 y0. And these all guys produce to give me my c value, which gives me 0, which is how we find our equation of the line in standard form. So the scalar or Cartesian equation of a straight line in a plane or two-dimensional space has the form n1x plus n2y plus c is equal to 0, where n1 and n2 is a normal to the line. So let's go to example 3. I want to find the equation of a line with a normal vector n, which is equal to 2 comma negative 3, that passes through the point 5 and 8. So what we can see from before, we have ax plus by plus c is equal to 0. My a and my b represent my normal vector. So my a is going to be my n1, and my b is going to be my n2. So I can technically already write this as 2x plus negative 3y plus c is equal to 0. And because I have a point already, I can just sub in those points for x and y to get my c. So I get 2 times 5 minus 3 times 8 plus c is equal to 0. So I got 10 minus 24 plus c is equal to 0. So c is equal to 24 minus 10, which means my c is equal to 14. Therefore, my equation is 2x minus 3y plus 14 is equal to 0. So now I want to rewrite a vector equation, x plus 7, y minus 3, comma r times the vector 2, negative 9 as a scalar equation. So remember, my scalar equation can be represented as ax plus by plus c is equal to 0. So let's identify some things first. What is the points that we're going to be using? If I solve for x and y on my left side, what is my points that I'm going to be using? So x plus 7, solve for x. Y minus 3 is equal to 0, solve for y. What is the point that I'm going to be using? Yep, negative 7 and 3, perfect. So what is my direction vector so far? What direction vector are we given? Remember, it's always the direction vector is always with the variable outside of it. Two and negative 9. So if my direction vector is 2 and negative 9, what does this imply about my normal vector? What would my normal vector be? Remember, when it comes to the negative reciprocal, my y is the one that always changes. Nine, 2. Thank you, Priyanshi. My normal vector is going to be 9, comma 2. So we can rewrite this as 9x plus 2y plus c is equal to 0. What points am I going to use to help me get my scalar equation? -7 and 3. I'm going to sub in x for -7 and y I'm going to sub in 3. So I get 9 times -7 plus 2 times 3 plus c is equal to 0. So I get -63 plus 6 plus c is equal to 0. So I get c is equal to 63 minus 6, and c is equal to 57. Which means my scalar equation is going to be 9x plus 2y plus 57 is equal to 0. Are you guys upset that we didn't do this earlier? Because your test would have been like 500 times easier if you guys had it on this. All this is taking grade 9 math and trying to make it look hard. That's what this unit is basically doing. And then we're going to go on to our last example, and that's probably going to be it for today. Holy smokes, I got in 2 lessons in less than an hour. That's pretty good. So parallel and perpendicular lines. So 2 lines with normals n1 and n2 in a 2-dimensional space are parallel if and only if the normals are collinear or scalar multiples of each other. Okay, so n1 is equal to n to k n2, where k is a non-zero real number. They are perpendicular if and only if the dot products give me 0. So for what value of k in line 1, so I got kx plus 4y minus 4 is equal to 0. And in line 2, I got 3x minus 2y minus 3 is equal to 0, are perpendicular lines. So I need to prove that the dot product of n1 type and the dot product of n2 give me 0. So in n1, my normal vector is going to be kn4. In line 2, my normal vector is going to give me 3 and -2. That just looked very good. So now I need to set their dot products equal to 0 and solve for k. So I get k, comma 4, dot product 3, comma -2 is equal to 0. So I get 3k plus 4 times -2, which is -8, is equal to 0. So 3k is equal to 8, divide both sides by 3, and I get k is equal to 8 over 3, which means that my k value has to be 8 over 3 in order for my lines to be perpendicular lines. Now we're going to get into some bit of a trick. So the angle between 2 lines is defined by the angle between their direction vectors A and B, where theta is equal to the cos inverse of A dot product B over the magnitude of A times the magnitude of B. So I want to determine the acute angle formed at the point of intersection by creating the following pairs of lines. So I have line 1, which is 2, 2 plus s bracket -1, 3. And then line 2, which is xy is equal to 5, 1 plus t, 3, comma 4. And but by A, B, it means the direction vector. So we're focusing on these guys only. So my direction vector for the first one is going to be -1, comma 3. My direction vector for 2 is going to be 3, comma 4. So I know that in order to find my acute angle, its theta is equal to cos inverse of the dot product of d1 and d2 divided by the magnitudes of both of them. So let's start with the dot product of d1 and d2. So my dot product of d1 and d2 is going to be -1, comma 3, dot product 3, comma 4, which gives me -1 times 3 plus 3 times 4, which gives me -3 plus 12, which gives me 9. So my dot product between direction vector 1 and direction vector 2 is 9. Now the magnitude of direction vector 1 is going to be the square root of -1 squared plus 3 squared, which gives me the square root of 10. Now the magnitude of direction vector 2 is going to be the square root of 3 squared plus 4 squared, which gives me the square root of 25, which gives me 5. So now I have all the information given, so I can find my theta value. So theta is equal to the cos inverse of a d1 dot product d2, which is 9, divided by the magnitude of d1 times the magnitude of d2, which is 5 root 10. So when I take the cos inverse of that expression, or that number, I get theta is equal to approximately 55.30 degrees.